All right, let's talk about something I bet almost every developer has done. You build a piece of software that, well, it just kind of happens, right? There's no big, grand plan. You just start coding. If that sounds familiar, then you've probably used the layered architecture without even realizing it. So today, we're going to pull back the curtain on this so-called accidental design that, honestly, powers a huge chunk of the digital world. So, really picture this for a second. You're on a brand new project. The whole team is super eager to get going, and everyone just starts writing code. There's no big architectural blueprint, no long, drawn out design meeting. You're just building. Does that sound familiar at all? I'm guessing it does. Well, if that scenario rings a bell, then congratulations. You've most likely built a layered architecture. We call it the accidental architecture for a reason. It's basically the path of least resistance. It's simple, it feels really intuitive to most developers, and hey, it requires almost zero upfront investment. You can just go. Okay, so what is it officially? What's the textbook definition? A layered architecture is an architectural style where you organize all your components into these logical, horizontal layers. Honestly, the best way to think about it is like a stack of pancakes. Each pancake is a layer, it has a very specific job, and they all just sit neatly right on top of one another. So why does this feel so natural? Why do we default to this? Well, it all comes down to this really fascinating idea called Conway's Law. And the law basically says that organizations design systems that are a mirror image of their own communication structure. Think about it. If you've got a UI team, a backend team, and a database team, what are you going to build? You're almost guaranteed to build a UI layer, a backend layer, and a database layer. The software literally copies the org chart. All right, so here's what we're going to cover. We'll start with the accidental architecture, then dive into the anatomy of a layer. After that, we'll talk about open versus closed layers, a super important concept. Then we'll look out for the dreaded sinkhole, and finally, we'll give you the final verdict. Okay, let's get into it. First up, anatomy of a layer. We're going to see how software is organized, a lot like an office building. The whole thing is built on this one core principle, and it's super powerful: separation of concerns. Basically, each layer has one job, and only one job. It doesn't need to know the nitty-gritty details of the other layers. So the presentation layer, it handles how things look, but it has no clue how the data is stored. And the database layer, it stores the data, but it couldn't care less what font the user is seeing. Each layer is a specialist, totally focused on its one responsibility. So in a typical setup, here's how a request flows. It starts at the top, right? Step 1, the presentation layer gets a click from a user. Then it passes that request down to step 2, the business layer. This is where all the specific business rules happen. Calculating a price, validating a form, that kind of thing. And finally, that layer talks to step 3, the database layer, to either save or fetch the data. The request just flows cleanly right down the stack. But here's the catch. There's a hidden cost to this, because this is what we call a technically partitioned architecture. A single business idea, like customer, gets sliced up and spread across every single layer. So if you want to make a simple change to the customer concept, well, you've got to touch the customer UI in the presentation layer, the customer business rules in the business layer, and the customer table in the database layer. One seemingly small change forces you to touch the entire stack. Ouch. Now, for this whole structure to actually work and not fall apart, you need some rules about how these layers talk to each other. And this brings us to a really critical concept: open versus closed layers. This one decision can seriously make or break your entire system. And honestly, the difference is pretty straightforward. On one side, you have closed layers. This means requests have to pass through the layer directly below. No skipping is allowed. Think of it like a building with no express elevators. You have to stop at every floor on the way down. On the other side, you have open layers. Here, requests can bypass the layer next door and talk to layers further down. It's like having that express elevator straight to the lobby. So why does this even matter? Well, the whole point of using closed layers is that you get this incredible benefit called layers of isolation. And this is the main reason you do it. If each layer only ever talks to its direct neighbor, you can do amazing things like completely swap out one layer. Let's say you want to change your database technology. As long as you keep the contract the same, none of the other layers will even notice. It makes the system incredibly stable. But you know how it is. The temptation is always there to take a shortcut. It just seems so much faster for the UI to grab data directly from the database, right? This is a classic pattern, sometimes called the fast lane reader. The problem is, the second you create that shortcut, you've just tightly coupled the top and bottom layers. They're now stuck together. And that means a change to the database schema could instantly break the UI. Your system becomes brittle, fragile, and suddenly very, very expensive to change. And speaking of problems, this brings us to a huge pitfall you really have to watch out for. It's probably the most common anti-pattern you'll see in a layered design: the sinkhole.
So what is a sinkhole? It's when a request passes through a layer and that layer does absolutely nothing. No logic, no processing, it's just a pass-through. Imagine you're just trying to get a user's name. The request hits the business layer, which does zero work and just forwards the request down to the database layer. That's a sinkhole. All that middle layer did was add overhead. Unnecessary processing, wasted memory, all for zero value.
So here's a good rule of thumb to keep in mind, kind of the 80-20 rule for sinkholes. If, say, 20% of your requests are just simple pass-throughs, okay, that's probably acceptable. But if you look at your system and find that 80% of your requests are sinkholes, just layers passing traffic without adding any value, that is a massive red flag. It's a sign that your architecture is actually working against you, not for you. Okay, so after all that, the pros, the cons, the sinkholes, what's the final verdict? When should you actually use this architecture? Well, it turns out it's a fantastic choice for a few specific situations. It's great for small, simple applications or websites. It's also a perfect starting point for brand new projects, especially when your budget and timeline are really tight. And, it's a good default when the final long-term architecture is still up in the air. In those cases, its simplicity is a huge strength. And this table here really tells the whole story. I mean, look at the top. Simplicity, 5 stars. Overall cost, 4 stars. It's super easy and cheap to get started. But then you look at the bottom. Testability and performance, only 2 stars. And scalability and deployability, a single star each. As your application starts to grow, these weaknesses go from being minor annoyances to major system-killing problems. So the trade-off is crystal clear. You get low initial cost and simplicity right out of the gate. But the price you pay down the road is in poor deployability and scalability. I mean, think about it. A simple 3-lined code change could require a full redeployment of the entire application. For big systems, that is a massive bottleneck. You just can't deploy quickly, and you can't scale individual parts of the system on their own. So the big takeaway here is pretty simple. Layered architecture is a phenomenal starting point. It absolutely gets you off the ground and running fast. But for applications that you know are going to grow, evolve, and scale over time, it's rarely the best endpoint. And that leaves us with one final, kind of provocative thought. Remember how we started with Conway's Law? The idea that our systems end up mirroring our team's structure? This architecture is the perfect poster child for that. But it makes you ask a bigger question. Should our future systems be limited by our current org chart? Or maybe, just maybe, should we start thinking about organizing our teams to build the kinds of systems we want in the future?